Like I said, problem number 24. Problem number 24, page 570 in your books. Solve the right triangle. Solve the right triangle. Okay? And this is my triangle. This is a triangle given to me that's a right angle. It may not look like that, but we assume it is. GHJ, right? Triangle GHJ. What else is given? I know one side is 2, one side is 6. And it says solve the right triangle, the round decimal to the nearest thing. What it means to solve the right triangle? We have to find one. Well, to solve the right triangle, it means to find all its parts, right? To find its sides and its angles. What can we find right away? We have two sides and one is missing. Let's call it X. Can we find that side? Absolutely. Well, we don't need any sine, cosine in this case. Why we don't need that? Because we can apply what theorem here? What theorem can you apply to find the missing side, Daniel? Pythagoras theorem. Which says what? That's hypotenuse, right? Pythagoras theorem is telling us that the sum of the squares of the short side, so I have 2 squared plus 6 squared should be the square of your x, right? What is 2 squared? That's 4 plus 36 equals x squared. It means that your x squared will be 40. To find x, you will take the square root of the right side, square root 40. Well, I'm not gonna use the calculator for this. I will just simplify it. Square root 40 is actually what? Square root 4 times 10, which is 2 square root 10, right? And I'm done. I'm done with finding my side, right? But now we have to find the angles, right? So we know hypotenuse is 2 square root 10. Now I have to find the angles. Well, one of them is given. It's obviously 90 degrees, right? But what about angle H? What about angle G? How can we find it? And in today's lesson, we are supposed to learn how to find a missing angle in a triangle whose sides we know. And this is what we're going to use. Sine and cosine functions. Say, what is sine of H? Sine of angle H equals what? Somebody tell me. Sine of angle H equals, what is the formula for the ratio for the sine function? Opposite over hypotenuse, right? So I have the opposite side over hypotenuse, which in this case, opposing H is 2. So it'll be 2 over 2 square root 10. You simplify by 2, then because you cannot have square root 10 as a denominator, you multiply by square root 10, and you find that your sine of angle H is square root 10 over 10. Now, in order for us to find the measure of angle H, we have to use the inverse of our sine function. The inverse of sine, right? So that's, it's written sine to the negative 1 of angle H, right? And how do you find that? You have to use your calculator and find what is inverse sine of square root 10 over 10. Alright? Well, it's actually not inverse sine of angle H, it's inverse sine of square root 10 over 10. Alright? Square root 10 over 10. Now you get your graphing calculators or even your scientific calculators. Let's see, do you have the inverse sine? Yes, you have. You have to use, well, first thing, turn it on. Then you have shift, and as you can see, sine is got a yellow sign to the -1. So you had shift, inverse sine, and what is the value? Use the parentheses, square root 10 divided by 10, right? And close the parentheses. And what do you get there? You get 18.43. Alright? So this is 18.43, approximately 18.4 degrees. Are we done? No, we're not done. We have to find G. Do I have to use sine of G to find that? Or I can find it right away because I know one of the properties of my acute angles in a right triangle. They're what to each other? In what relation? They're complementary, right? So if I know that the measure of angle H plus the measure of angle G equals always what? 90 degrees in the right triangle. Which means the measure of angle G will be 90 degrees minus 18.4. I can do it here. Hold on. I can write 90 on the top of this 18 right here and just perform that subtraction, right? So I have 4 out of 10 will be 6 decimal point, right? 8 out of 9 will be 1. 1 out of 8 is going to be 7. And that's the measure of your angle G. 71.6 degrees. I got angle H. I've got the sides. This triangle is solved. Any questions?